Good morning, our listeners, and welcome to this morning's class. Today, we want to quickly look at some problems, especially concerning the one that we left as an assignment in our previous class. Do you remember that in our last class, we began looking at equations in matrix? And when we solved some, we decided to leave one for our audience to try out at their convenience time. So we have deemed it fit today to begin our class by revisiting that problem we left to profile solutions to it so that some of our audience who tried it will be able to cross-check their answers. So let me call up now the question on the board and then we solve it. And then I urge you that if you attempted it, cross-check your answers to see whether they tally. Thank you very much. That question says, and I write, it says solve. Question says solve, solve. Okay, this is 2, this is 1, this is minus 3, and this is what? 3. This is x, this is y, and this equals 1 and 2. This is the question, and you are asked to solve it. And do remember that we earlier had mentioned that when we are given expressions in mathematics in form of equation, that's the major thing that we are required to do there is to find the values of the unknowns. Value of the unknown, if we are talking about a single equation, of the unknowns when we are talking about simultaneous equations. Looking at this question we have here on the board, we have x and y here, telling us that there are two unknowns that are involved there. For the fact that there are two unknowns, one begins to condition his mind towards solving the problem using the approach of simultaneous equation. That is, two systems of a linear equation or two systems of one linear and one quadratic equation solved concurrently. And equally, the question before us now appears in form of what? A matrix. And therefore, we have to operate, or we have to apply the operation of what? Of a matrix on it first to see if we can successfully transform it now into simultaneous equation. How do we do that? We begin. Remember that in our last class, we made it clear that for us to multiply out matrices, there are two matrices here. The first matrix, which is a 2 by 2, with the entries 2, minus 3, 1, and 3. And then the second matrix, which of course is what we call a column matrix, 2 rows and 1 column. These are two matrices. So we first of all need to multiply them out now and equate them to this. So what I'm going to do becomes, we are to use the first row of the first matrix to multiply the first column of the second matrix. That is the order of multiplication. And for that reason, we go together. So permit me to divide this board this way, permit me to divide the board this way, and then begin by writing solution. Begin by writing solution. So what I have here becomes now, here I open my bracket this way. So here is 2 times what? X, which will give me what? 2x. And I'm now here, so I'll say plus. Minus 3 times y will give me minus 3 what? Y. I am done using the first row to multiply the first column. So I come back now to use the second row to multiply the first column. So 1 times x will give me what? X. Here is my 3. So I have plus. 3 times y will now give me what? 3y. Then I will close it this way. This is equals, I was told, is 1 and what? And 2. Now in mathematics, we should bear in mind that plus minus is minus. So on that note, what I have here becomes that I have this in this way. I have this is 2 what? X. This is what? Minus what? 3 what? Y. This is what? X. And this is plus what? 3y. Then I'll close it this way. This equals, I'll open here. Here is 1 and here is what? 2. Let me recall what I earlier had said, that in mathematics, wherever place we see plus minus, the answer is minus. Wherever place we see minus plus, the answer is what is minus. So that was why this was able to be transformed into this. And of course, when two matrices are equated, what is implied there is that the corresponding entries are equally equal to each other. How do I mean by this? This is what a matrix and this is a matrix. This is a column matrix. That is two rows and one column. This is equally a column matrix now, two rows and one column. So the implication is that the first entry here must be the same thing with this entry here, and the second entry here must be the same thing with this entry here. And in that case, what I have here becomes, what I have here is what? 2 what x minus what? 3 what y equals what? 1. And what I have here becomes what? X plus what? 3 what? Y equals what? 2. I can call this equation 1. I can call this what? Equation 2. Permit me to remove what came up on my screen. Now, of course, there are many approaches now through which one can resolve simultaneous equation in terms of evaluating the unknowns. Approach of a substitution method, approach of a simultaneous elimination method, approach of even graphical method. But then let us now use the approach of a substitution method here, in as much as that equation 2, the x stands what alone. So we can easily come to the second equation now, make x subject of formula now, and bring it back to the first equation now to substitute. And then, of course, from equation 1 now to 2, now you know, if I want to make x subject of formula now, this 3y goes over there. And what I'm now going to have becomes what? X is equals what? 2. This plus 3y coming over here now takes what? Minus. So I have what? Minus what? 3y. So from equation 2, I've got to know that x equals 2 minus 3y. So I'll come back to equation 1. Anywhere I see x, I'm going to replace with 2 minus 3y. So I will now say therefore, here is my 2, so I will now write what? 2, open a bracket. Instead of writing this x now, I'm going to write 2 minus 3y. So I have what? 2 minus 3 what? Y. Close it. The sign I have here is what? Is minus. So I have minus what? 3 what? Y is equals 1, which is what I have. Then I will open a bracket with this 2 outside. 2 times 2 will give me what? 4. The sign here is what? Minus. 2 times 3 will give me what? 6 what? Y. Minus this what? 3 what? Y. This will be able to give me what? 1. Now I move on. Here becomes what? 4. What this means is minus 3y, minus 6y, minus 3y. You are owing 6y. You are equally owing 3y. So the altogether or the aggregate of your debt becomes what? 6 plus what? 3, which is what? 9. So you have minus 9y here. So this minus what? 9 what? Y equals what? 1. Of course, this and this are what we call like terms and should be collected what? Together. So collecting them together means taking this 4 now to go over there to meet 1. And when 4 is going over there, it takes the value of what? Of minus what? Sign. So what I now have becomes what? That I have minus what? 9y is equals to 1 minus what? 4. And of course, this implies that 1 minus 4 means you are having 1, but you are owing 4. So when you pay the 1 you are having, then you'll be owing what? 3. So this implies what? Minus what? 3. So I will say therefore, minus 9y equals minus what? 3. To make y to stand alone now, I will divide both sides with the coefficient of what? Y, which is a minus 9. So this is all over minus what? 9 and all over minus what? 9. So at minus 9 can cancel minus 9. And I'm left with what? This thing becomes y is equals. Here is minus and minus. Minus and minus will cancel off to give me plus. Here is my 3. 3 into itself is what? 1 all over. 3 into 9 is what? Is 3. So I now come to terms that my y equals 1 over what? 3. Now with this y which I have found, I'll now come back now to this expression where I had that x equals 2 minus 3y. Now I have known the value of what? Of y. So I'm going to place it in place of this y now in order to know the true value of my what of my x. So I will now say recall that. I'll say recall that x equals what? 2 minus 3y, which is what we had from equation what? 2. But our y now is giving us 1 over what? Over 3. So I will now substitute the place this 1 over 3 now in place of what? Y in this equation. I will now say therefore my x now is giving us, here is my what? 2 minus, here is my what? 3. I won't write y again. What I'm now going to write that place becomes what? 1 over 3. So I will now open the bracket and have 1 over what? 3 and close up what? The brackets. So here I have 3, here I have 3. So this 3 can cancel this 3 off. Then, of course, when 3 goes itself is 1, goes into this 3 is what? Is 1. And 1 times 1 is what? Is 1. And 2 minus 1 will give me what? 1. So I'll say, therefore, my x is equal to what? 1. So you see that using the approach of substitution method, we have realized that my y is 1 over 3 and my x is what? Is 1. So we now say, therefore, my x equals 1 and my y equals 1 over what? 3. If you attempted this question, we encourage you to cross-check the answers that you had to see if it is something similar to what we have on the board. And then if you have a different answer and you are convinced that your approach is legit, then it means you need to drop your comment in the comment section telling us exactly your challenges and why your own answer derailed or deviated from these solutions provided here on the board. Thank you very much. Then let us officially go into what we have today. Since we began the discussion on matrix, we talked about matrix operations, which of course we said cut across the addition, the subtraction, the multiplication. In multiplication, we have two categories. We have the scalar multiplication of matrix and then the normal, usual multiplication of what? Of matrix. We looked at all of those and entered into equation in what? In matrix. And today we want to go into the next thing that is done in matrix, which is called determinant of matrix. We are going to take it stage by stage. First of all, look at what we call determinant of 2 by 2 matrix before we now go into what we call determinant of a 3 by 3 matrix. So we want to do it this way so that we'll be able to carry our students what along, especially when they would want to revisit our previous videos in order to fully participate in our classes as it regards metrics. Thanks for your audience and stay put while I wipe the board and we go into officially determinant of metrics. Determinant of the matrix. Determinant of matrix. Let me talk that matrix what? A. And that matrix A is 2 by 2. That matrix A is a 2 by 2 matrix. So we want to talk about determinant of what? Of a matrix A, where that matrix A is a 2 by 2 matrix. There are two ways of denoting a matrix in what? In mathematics. If that matrix is defined as what? A, the determinant of this matrix A can be written this way. For instance, if the matrix is what? Is A, then if you talk about the determinant of this matrix A, you either denote it with what? This is called determinant of matrix what? A. Or you can write it this way, det of what? Of A. This is understood as determinant of matrix, and this is equally understood as determinant of a matrix what is A. But today we are talking about 2 by 2 matrix. So it is better we define a 2 by 2 matrix that is denoted by a letter A. So we now have our A this way, and that our A this way is given as entries are what? A, we have B, we have C, and we have D. This is what we have. And then when we are told to find the determinant of this matrix, how do we go about to find it? It is very simple. It is the product of the leading diagonal minus the product of the minor diagonal. This is what we call the leading or the major diagonal in the matrix. And this is what we call the minor diagonal in the matrix. And when we talk about the product of the leading diagonal, we are saying the product is the multiplication of the entries in what? In the leading diagonal. So we now say, therefore, the determinant of A, which is written as this, is given as A times D will give me what? AD. AD minus. My C times B will give me CB. This is what we give as determinant of a 2 by 2 matrix. Therefore, you can equally see where someone will write that of what? Of A is given as what? AD minus what? CD. Don't you see that finding the determinant of a 2 by 2 matrix is very simple? We are going to actually be challenged with some examination questions from Jamb, from Waec, from Screening, and from some other higher examination bodies that actually revolve around 2 by 2 matrix, but pose some challenges because they require some level of critical thinking. We are going to evaluate all of those today. So by implication, we have few questions here which we are going to call on the board and use the idea of this little introduction now to solve them with you. Thanks for your audience. Do remember to subscribe to our YouTube channel and then follow up all our classes. Thank you very much. So permit me to click here. The question say, and I write. Question number 1 says, and I write. Very simple question. They say find the determinant of A equals, I have 3, I have 4, I have 1, and I have 2. So let us quickly solve that without wasting time. So by way of solution, permit me to divide the board this way. By way of solution, or let me write this way. That question says, solution. We tell ourselves, recall that A equals A, B, C, D implies that determinant of A is given as AD minus CD, which we earlier established. So just opposing this particular matrix here with what we were given. We now say, therefore, A equals 3, 1, 4, and 2 implies that determinant of A is given as, here was AD, which is this, so it's going to be 2 by this. So I have what? 3 times 2, this 3 times 2, the sign here is minus. Here was CB, which is what we have here, CB, which is what we have here. So which is 1 to what? To 4. I have 1 multiplied by what? 4. So this thing becomes 3 times 2 will give us what? 6 minus 1 times 4 will give us 4. And then 6 minus 4 will imply that the answer is 2. So the determinant of this matrix is what? Is 2. It's just the product of the leading diagonal minus the product of the minor diagonal. Let us take another question on again from the book. This one is not difficult. The second question says, and I write, I'll be fast. The second question says, find, that is number 2, find that A, find what? That A, if A is given as, we have what? A is given as, we have this one to be 2, you have 2, you have 6, you have -1, and you have 4. That's what you have. So let us attempt this one very fast. So as a way of solution, we equally recall for ourselves that A defined as A, B, C, D will imply that determinant of A is given as AD minus CD. This minus that. So juxtaposing with this or matching this thing which we have been given to what is here, we have that this one is that A defined as 2, 6, -1, and 4 will imply that determinant of A will be given as, here was AD, so I will have 2 and 4, which is 2 times what? 4 minus, which is what is here in the formula. So what I had here was CB, which is what I have here. So I have this and this. And this means -1 times what? 6. So I have what? -1 times 6. I will close it up. So this equals 2 times 4 will give me what? 8. The minus is here, minus. -1 times 6 will give me minus what? 6. And of course, in mathematics, minus minus will give me plus. So this implies 8 plus 6, which is equals what? 14. So 14 is the determinant of that particular problem. Okay? Without wasting much of your time, permit me to clean the board. Let us draw up another question. Let us solve as many problems or questions as possible so as to establish your understanding around the determinant of a matrix, especially as it concerns 2 by 2 matrix. Okay, this question says, and I write. The question says, and I write. I'll be fast. That question